Good afternoon. My name is Bruno, and as Hugo said before, I'm manager at LTB Labs, and I'm going to present you here a use case that we developed with a car rental company. I'm proposing first to start a bit about the context and the goals of this project. Then we are going to take a small deep dive on our technical approach, get some implementation details, and then go to the key results as well. Since Gonzalo set the stage for optimization, my life will be much more easier now than before. Just for a quick context about the problem itself, it is a car rental company that works mainly here in Portugal, or at least in our subject of analysis, just for the Portuguese market. But in this situation, the car company is in the top 10 of Europe and the world, I guess. Its location is Portugal. Here, they have 40 stations that are aggregated in pools. Like, for example, in Porto, we might have a station that is next to the airport and also a station that is downtown in Porto. They have 52 vehicle groups, like based on their size and characteristics. And our key goal was to set the price and also the fleet rotation between stations, and based on optimization, as I mentioned before. Just a quick overview of what is happening before the project. Before the project, these technical decisions and operational decisions were not integrated with each other. It was based on manual price changes and manual fleet rotation. The price is empirically defined based on their own rules and rules that they craft manually based on some basic statistic analysis. The fleet allocation and price were not integrated, was two separate decisions. And here we aim to take a look at this and build a strategic model. In this case, what we call an analytic revenue management platform that integrates both the fleet decision, like changing cars between different stations, and also optimizing the price along the way, like setting the price at the optimal setting point for increasing revenue and profit in the near future. So the project itself aims to get a better predictive capability of on rents, get a dynamic and more granular pricing decision. By dynamic, I mean doing this in the daily basis, not only when people are around and can change the prices. Have a synchronization between the price and the fleet and the operation strategy, and get a better coordination between all the decisions that the company itself wants to make. So, and how did we do it? First, we need to divide two separate worlds. One is the monthly review, so it's a more tactical decisions that we need to make, like what will be the monthly target and the price strategy for that particular month. And then we move to the daily operation and the daily decisions. On the daily decision, what will be the key focus of this presentation? We want to change prices daily and also change the fleet size of each station by moving cars around, and with the key goal of setting the profitability in the highest point possible, like take into consideration the revenue and also the cost of operational cost, and also moving around cars between different stations. So, in a more detailed way, we divided this into three different streams. The first one is on rent forecasting module. What we aim here, we aim to get a forecast, an unconstrained forecast of the demand for a given day based on a specific set of parameters. What I mean with that? Okay, when we think about demand and offer, we are focused on the demand part of the problem. Like, we want to get a forecast that can predict what will be the demand for a given vehicle group in a given station for a given day, for a given duration, based on a set of conditions that can be intrinsic or extrinsic in this case for the given car company. Then we have an optimization module that will use that demand that we calculate before to understand on the offer part, okay, what cars do I have available? What will be the best set of prices that I need to make in order to maximize the profit in the end of the day? And then we have a repositioning model that I won't detail here because it's more operational and less interesting to present, let's say. Focusing on the forecasting module, we leverage variables like price of the competition, the current state of on rents, like the rents that have already on the wallet of the company. We also take into consideration intrinsic factors like the number of available of different cars that are available in the market, and if there is any external event like Easter or Christmas that typically increase the demand of the cars, with the aim of getting a demand forecast for a given date, a given vehicle group, for a given station. Then we use this, as I said before, for our optimization model. Just for a quick context, we know the price elasticity curve. But in the end of the day, this is very difficult to get, and it changes all the time when the competition changes prices, or for example, if there is an external event going on. So for this curve, we leverage the forecasting module that I presented before that tries to somehow, instead of trying to address the curve, setting multiple points and make this from a continuous decision to a discrete decision. Okay, we know based on their operation that not all prices are available. They have like this price ladder. Okay, they might have a price per day of 20 euros, but there isn't any price that is 20.10 cents. The next price step will be 22 or 25 euros. So the decision is discrete despite the price elasticity curve is continuous in that sense. So we discretize this continuous distribution into at least 10 discrete price points that the car can have in a given time. Then we have another problem. Okay, we are trying to address the demand for a given day, but this is the reservation day. And right now, I might have reservations for 2 or 3 weeks ahead. So we need this ABT curve, which is the advanced booking time. Okay, that tries to mimic, and this is specific for each vehicle group, product, car, or even station, that tries to mimic the behavior of our customers over time. For example, if I was 8 weeks in advance, so I expect to have an occupancy rate of, for example, 30% based on my target. So I'm expecting to have more 70% of rentings until the pickup date, which is the date that all the cars will be delivered to the customers. So the key idea here is to combine this curve with our target that is provided by the forecasting module. So here, if I have, for example, an expected demand of 100 cars, and right now I'm in the 8 weeks in advance, and the 8 weeks, and my occupancy target is 30%, I expect to have, if I have, for example, 50 cars, I expect to have more 70% based on those 50 cars that I have right now. So I'm a little above the target or below the target for a given day. And based on these two decisions, or two factors, we want to make 2 decisions. And the 2 decisions is quite simple. Car transfers between stations and price optimization. For example, I have here station A to station F. For example, on station A, I will need more 153 cars based on the current projection of on rents. But on station F, I will have a huge slack of cars if I keep going this way. So I can make two decisions here. I can transfer car from station F to station A without changing prices, or I can increase the price of station A and decrease the price of station F to rebalance my model. And the key idea is not to doing one or the other, but doing both at the same time and optimizing the profit in the end of the day. So we have two different decisions. We have one objective function, which is maximizing the profit, revenue minus costs. And this is not a simple problem, because in the end of the day, we have a lot of constraints to have here. First, we have targets that we need to meet at each station. We have a minimum and a maximum price that we need to comply with. This is operational restrictions. We have the relations between prices. We cannot have a price that is higher for a more premium car, for a less premium car. So we need to maintain these price ladders. We have a minimum and a maximum fleet at each station, because the stations have their sizes. So despite the airport station is very attractive, we cannot put all the cars there. We need to get this balance done. We have also the operational capacity, and we have costs of repositioning vehicles, so we need to take everything into consideration. One thing that makes this problem not daily dependent is actually the dependence that we have between days. Every time that we have a reservation, we might have a reservation of 1 or 2 days, or 1 or 2 weeks. And that will be different regarding the availability of cars at each point in time. So we need to take everything into consideration. That's why, for example, for this day 2, we need to take into consideration the third line, and also almost the last line, where we have a length of 30 days, but it was that specific rent will only start on day 2. So, taking everything into consideration, I have here some print screens of the model that we use. If you want to get further information, I will provide it to you. I'll be here, and you can address me all the questions. First objective function, as I said before, our key goal is to maximizing the expected profit, take into consideration not only the operational cost, but also the repositioning cost between pools and between stations. Then we have a lot of constraints, like one price step per vehicle group. We have fleet constraints, like the total fleet size, the minimum fleet size of each station, of each pool, and the transfers. We have the maximum transfer between stations and between pools, because there is some limitation in terms of operational capacities. We have the price order, and the daily operational capacity also is something that's taken into consideration in the end of the day. So this is somehow the problem that we addressed. Let me just take some notes about the implementation details. To put everything in order, we use Gurobi as the main engine for our optimization module. We also use Pulp as the open library to craft this model. One thing that I want to notice is that this specific optimization model was crafted specific for this problem, because the constraints and the objective function only works based on these specific problems and these specific circumstances. We also use Kubernetes and automated triggers to set everything and to really feed this car company with the price decision and fleet movement recommendations for the future. Because the problem is really large, we need to take this problem into chunks, and we use a methodology, a famous methodology that is relax and fix to do this. So we optimize this in a rolling windows, just to minimize the number of variables that we are considering, and also take a model, take small models that the server that we are using is able to get a true answer. Otherwise, it will be difficult for us to put everything into place due to the number of variables that we have. The calculation is very simple. If you multiply the 10 price steps by 40 stations, by 52 price groups, by 10 steps, by X numbers of on-rent duration, we'll end up with more than 100,000 variables. That is too much to run at every time. So the key results. We potentially generate more than 1.5 million prices per day. One thing that I want to highlight here is that we are more control between the tactical level and the operational level. We have more faster and semi-automatic reaction to the prices and how is the current on-rent occupancy at each time. The current projection based on testing pilot that we do points to from 2 to 8% of revenue increase, which is a lot in this type of projects and in this type of companies as well. And so we change, at least try to change the paradigm of the team that is behind this project as well. Thanks a lot.
Hello again. So, if you still have any doubts for Bruno, please drop it in the app. While we wait, Bruno, we have probably time to your questions. So, I will try to question one that I'm curious that this is a big beast of decisions and constraints, and then to really apply the algorithm in the different stages as you present. But from your point of view, what is the more complex part trying to find this solution? Where is the biggest the biggest challenges to really put a solution like this in place?
The biggest challenge, if I might present at least one, I will say the number of variables that we need to manage. In the end of the day, we are making decisions that one decision impact the other. So the number of variables that we end up to decide, it's more than 100 million, as I said. So we need to trim down the number of variables in order to be able to get a solution and an optimal solution. So we have a 4-hour windows to generate prices for the day. And we cannot miss that 4-hour windows, so we need to work hard on the duration of our execution in order to be able to get prices and fleet recommendation during that time windows. So I'll put that as the key difficulty.
Great. I think someone is challenging you about the meteoristics that was presented before. If it will help dealing with this inherent complexity and stability of the problem itself. What are your thoughts on that?
Yeah, we use some meteoristics. Some of them are already built in the Gurobi engine. So the Gurobi have meteoristics behind it we can use to leverage the initial solution, and we use those. I didn't present that because of the time that we have to present the use case, but we use those, and those help us to get at least a good initial solution. But then we have the optimization part, and we cannot disregard that part because that part is also very important to get not a good solution, but an optimal solution, which is our key goal.
Great. Someone questions you about the need to optimize for competitor price and availability. If you are a priori, you did this for the competitor prices and availability in the competitors, if it's something that you take into account or you are planning to?
No, we take that, definitely we take that into consideration because it's a very competitive market to begin with. So that part specific was on the demand part, so the forecasting part, where we want to check what is the true demand for that vehicle group for a given station during that period. We use those kind of variables like the competitor price on our forecasting module in order to fine tune what will be the outlook for the demand of the car rental company that we try to help during that period. So that it was in that part of the project where we leverage the competitor price to catch.